Because this is so magic, we're learning physics together. It's magical. Let's do question 40. Question 40. You have a car of mass 1,900 kilograms. You have U is equal to 0. You have V is equal to 27 meters per second. You have time is equal to 8.1 seconds. A. Calculate the average rate at which EK is supplied to the car during acceleration. So, what is average rate? What is this? Average rate is per unit time. And you can already see we entering into power, which is work done over time. Twin of work done is energy over time equal to force times velocity. Here your work done will be your kinetic energy, half mv squared over t. Your m here will be 1,900 kilograms, typical mass of a car. And you have a speed of 27 squared. Remember, if we're looking at this, we can consider that to be minus half mu squared in order to find the complete change in kinetic energy. But since u is to 0, we can omit that side. But do remember, if you have a non-zero u, you have to add that component here. Your time here is 8.1 seconds. So please use calculator, and hopefully by the time you unpause this video, you should get a value of around 8.55 times 10 to the 4 watts. And what does it mean again? It means that 8.55 10 to the 4 joules is used for every second to power this vehicle. Now the next question. The car engine provides power at a constant rate. Constant rate. For the power, the basis power is the constant. So I just explain why the acceleration of the car is not constant. Why is, since constant rate of power, why is the acceleration not constant? Okay? You will sort of have a good idea of what we're talking about here. The reason is because of this fact. Sometimes the statement you must remember. A, resistance increases with speed. The faster you go, the higher air resistance. You will standing there stationary, you don't feel anything. But once you start walking, you feel air resistance. Once you start running faster and faster, the air resistance increases. Okay? So that's a fact. So the driving force and the acceleration, the driving acceleration, will therefore be reduced. Meaning, as air resistance increases, if you use constant force throughout, you notice if you're driving a car, you probably have to push the pedal more in order to make sure. If you want to keep the acceleration constant, you have to push your pedal more. If not, what you realize, even though your engine is providing constant rate, you actually will slow down. Okay? Difference between driving on a flat plane where you literally have a nice smooth ride, but if you go up and if your air increases, you will slow down. I hope you understand this video. If not, please replay this